Elementary Algebra, Final Assessment 4, Review. Questions 8 through 10. Outcome 2, Solving. Question 8's instructions simply read solve. If we look at the question, we're given a trinomial, 8y to the second power, 22y plus 15. Because it's in the form of a trinomial, we'll solve by factoring. So we have a trinomial in the form ax to the second power plus bx plus c. We'll start by pulling out what's in the a and the c position so that we may use the a times c method. In the a position we have an 8, and in the c position we have a 15. Multiplying these two items together give us 120. Next, we want to pull out what we have in the b position. In the b position, we see we have a 22. Next, we're going to look for factors that when multiplied together equal 120, but when summed add up to 22. We'll start this by creating a list. Typically, upon looking at the number, if you're unsure of the correct factors, then simply start at the beginning with 1 and work your way down the list until you find the correct set of numbers. So we could begin here with 1 times 120, which equals 120. When we look at summing these two factors, we get 1 plus 120 equals 121. Now, we might move on to a 2, but we can see right away that 121, we're still quite a ways off. So perhaps taking a 2, a 3, or even a 4 might still be too far away from our goal of 22 for B. So let's try, because it's ending in a 0, a 5. We know that 5 will go into it. If we take 120, divide it by 5, we see it goes in 24 times. So 5 times 24 is equal to 120. Moving over, 5 plus 24 gets us a 29. We're getting a little closer. Let's try to see if a 6 will work. If we take a 6 and divide it into 120, we see it goes in 20 times. So 6 times 20 is equal to 120. So coming over here, a 6 plus a 20 is going to equal a 26. That one's still not working. So perhaps we would try a 7. Well, when we try to divide a 7 into 120, we see it won't go in evenly. So let's move on to an 8. An 8 will go in 15 times, so 8 times 15 is equal to 120. 8 plus 15 is equal to 23. We're almost there. What about a 9? A 9 won't go into 120 evenly, but we can see it ends in a 0, so we know a 10 will. So let's move on to the number 10. 10 will go in there 12 times, so 10 times 12 is equal to 120. 10 plus 12 is equal to 22. So we found our two factors. We found our two numbers that we want to work with. So now that we found our numbers, we're going to rewrite the original trinomial, which was 8y to the second power plus 22y plus 15, replacing the center 22y with the two new numbers. So we rewrite this as 8y to the second power plus a 10y plus a 12y plus a 15. We haven't changed the original problem. If we sum the two middle terms, we still come back to 22y. But now that we have this in 4 terms, we can factor by grouping. So I'm going to put my parentheses around it. I'm going to look to see what will divide out of each binomial that I've now created. With the 8 and the 10, I know that a 2 will divide out of each, so I'll put a 2 down here. I also can see that I can take one y, so I'll take a y as well. So when I divide these out, the 2y comes to the outside, and I'm left with 2 into 8 to leave me with a 4, a y into a y to the second to leave me with a y, plus 2 into 10 to leave me with 5, and the y's, y into y, that's 1. 1 times 5 is still 5, so it canceled out. Carry down my plus sign. Now I come over here and I see a 12y to a 15. So I know that a 3 will divide out of both of these. So I pull a 3 to the outside. 3 goes into 12 4 times, carrying down that y, carrying down that plus sign. 3 into 15 leaves me with 5. So now looking at this, I can see that each of these has a 4y plus 5 and a 4y plus 5. So I'll divide that 4y plus 5 out of each side. So 4y plus 5. This gives me my 4y plus 5. So these are canceled. What I'm left with is a 2y plus a 3. That creates my second binomial, 2y plus 3. Now I factored it completely. Next, I want to solve. I'll do this by setting each binomial individually equal to 0. So I will rewrite my binomials down here, my 4y plus 5, and set it equal to 0, and my 2y plus 3 equal to 0. And I'll solve for y. Let's start with the first one. I'll solve by moving the 5 out, so I'll subtract it off both sides of the equal sign, keeping it balanced, so that I have a 4y plus a 0 equals a negative 5. Next, I'll divide this 4 that's multiplying to the y. Whatever I do to one side, I do to the other, so I will divide it out on the opposite side as well. So this leaves me with a y on the left side and a negative 5/4 to the right. So I've solved for one of the binomials. Next, I'm going to come over and solve for the second binomial. I'll start out the same way. I'll subtract that constant off both sides, in this case a negative 3 or minus 3. This leaves me with a 2y plus a 0 equals a negative 3. Next, I'll divide out this 2 that's multiplying to my y. Whatever I do to one side, I do to the other, so I will divide the 2 out on the other side of the equal sign as well. Crossing this out, I'm left with y to the left is equal to a negative 3 over 2. So here are my answers, a negative 5 over 4 and a negative 3 over 2 when solved. Question number 9 comes with the same set of instructions, simply to solve. So I'll start to solve the problem by pulling this 9x over to the left side, hence leaving a 0 on the right side. So I'll subtract a 9x off both sides, minus 9x. When I look at this, the 4x to the second power and the 9x are not like terms, so I can't subtract them. But I can write it out just to show mathematically what I'm doing. So I have a 4x to the second power minus a 9x, which equals a 0. Now I'm ready to start solving the problem. When I look at them, I can see that I can factor an x out of both sides, or both terms. So I'm going to come in here and factor out my x. 1x here and 1x here. This brings the x to the outside. Inside, I'm left with a 4x minus a 9. Now I'm ready to solve. I've factored this as far as it can go. I'm going to set each individual term to 0. So this x over here is going to be set equal to 0. This is actually one of my answers, 0. The other, the binomial, is also going to be set equal to 0. So I end up with 4x minus 9 equals 0. Like on question number 8, I'm going to subtract the 9 off both sides. So I subtract out the 9. I'm left with a 4x equals a negative 9. Next, I want to get the 4 away from the x. I'll do this simply by, those are pluses, simply by dividing the 4 out, or dividing the 4 out on this side. So my 4 goes away. I'm left with x is equal to a positive 9/4. So here are my two answers. I have x equal to 0 and x equal to a positive 9/4. These are my final answer. Question number 10 also reads to solve. Before I solve this, I want to simplify it. So I will distribute this 2x through the parentheses. So I'll take this 2x to the 2x, which makes a 4x squared. I'll take a 2x to a negative 6 to create a minus 12x. And then just simply carry down my equals negative 9. Now I'll bring this 9 over to the other side to create my trinomial. So I'll add a 9 to both sides, plus 9, plus 9. Because the 9 is not alike with either of the terms that already exist, I'll just simply write out the trinomial. I have 4x to the second power minus 12x plus 9. Now I'm ready to use the A times C method to solve. So I'm going to take what's in my A position and what's in my C position and multiply them together. This gets me a 4 times a 9, which equals 36. Now I want to pull out what's in my B position, which is a negative 12. So negative 12. From here, I want to work my way down, finding factors that when multiplied together create a 36. Well, if you know a little bit about your math, 36 can be created by multiplying 6 times 6. When summed, that's going to create a 12, but I need a negative 12. So I need to come back over here and place on both of my 6's a negative, because a negative times a negative still will create my positive. But when I sum it together, my negative 6 plus my negative 6, I get my negative 12. I found my two numbers to replace my middle term. So let's go in here and do a little rewrite. I'll take the original problem, the 4x to the second power, but this time instead of writing minus 12x, I'll write minus 6x minus 6x plus 9. It's still the same as the original problem. I still have a minus 12x when I sum these two together. Okay, I've pulled the page down a little bit to give us a little more space to work. Next, I want to factor by grouping. But before I actually place my symbols or my parentheses around my two terms, I want to notice that I have a negative to the center. Because I have this negative to the center, I want to rewrite it as a positive and push the negative over onto the 6x. Because if I wait until after I put in the parentheses, it'll look as though there's a negative that's intended to move to both of the terms rather than just one. So at any time you see a minus sign to the center, just before you do grouping, make sure that you rewrite it as a summing problem. Alright, now looking at this first one, I see that I can divide out a 2 from the 4 and the 6. I can also divide out an x, because each one has an x to give. So this rewrites as 2x, leaving inside a 2x minus 3. Carry down my plus sign. Now I look at this negative 6x and this 9. Whenever you have a negative in the first position, make sure that whatever value you're dividing out, that it's going to be a negative. So here I'm going to divide out a negative 3, because I can pull a negative 3 out of both terms. So my negative 3 comes to the outside, and I'm left inside now with a positive 2x. A negative 3 into a positive 9 creates a negative 3. Last step, I need to come in here and divide out my 2x minus 3 from both sides. So I'm going to divide out a 2x minus 3 here, and I'm going to divide out a 2x minus 3 here. So these pulled to the outside, 2x minus 3. What I'm left with is a 2x plus a 3. So coming down here, I'll rewrite that. I get a 2x minus 3. You notice both of my binomials came out the same. Another way to write this is 2x minus 3 raised to the second power. Because they're identical, I only need to solve one time. So I'm going to take my 2x minus 3 and equal it to 0. Now that we have this equal to 0, let's go ahead and solve for x. We'll start by adding a 3 to both sides, so plus 3. This creates a 2x plus 0 equals a 3. Next, we'll divide out this 2 that's multiplying to my x. So as I divide out the 2, I'm left over here with an x. On the other side, I'm left with 3 over 2 for my final answer.